Good day everyone, we are Group 4 and today we are presenting our assignment on the railway track and the wheels for the subject of the railway engineer mechanic. So our discussion will include the material used with fabrication process, specification and more. So the railway track and the wheels are essential components that support the train operations, and their material strength and structural integrity readily influence the reliability and the safety of the railway system. So technological and advancements has improved their reliability, allowing the higher speed and a heavier load. The material used in the railway track and the wheels are chosen for their mechanic strength and resistance to stress. So the high carbon steel is ideal for the track due to its hardness, while the ferrous alloy steel is preferred to the wheels due to its toughness and crack resistance. Railway tracks are primarily made from the high carbon steel such as R260 and the UI616. So this type of the steel is wear resistant, capable of withstanding the continuous loading, and offers the dimensional stability under the verifying the operational condition. So the railway wheels are used the focused medium carbon steel with the added alloying the elements to improve the toughness. Standards such as EN 13262 and AAR Class C ensure the wheels meet the safety and the performance requirement, so including the fatigue and the thermal resistance. So the advantage of the high carbon steel in the track include its ability to resist the wear and deformation, handle the heavy train loads, and maintain the performance over the time. It is also widely available and economical for the mass production. So the focused steel in the wheels offers the toughness to absorb the shock load and maintain the integrity under the stress. So the fogging process refines the steel's internal structure, ensuring a longer life and a better performance under the thermal and dynamic force. So next, for the fabrication process, the fabricate of the track begins with the steel making and the hot rolling, so followed by the heat treatment. So the wheels are focused and machined to the precise profile, then heat treated for reliability. So the both process include the rigorous inspection to meet the quality standards. So the international standard like UIC16 for track and the EN 13262 for the wheels define the required material properties and dimension. So adherence to this ensure the components can withstand the high speed and the high load operation safety. So lastly, in the conclusion, the railway tracks and the wheels play a crucial role in the rail industry. So the right material, proper fabrication, and adherence to the standard ensure their reliability and longevity. So continuous innovations promise even the safety and a more efficient railway system. That's all for me. Thank you.
My name is Anderson Tin Kai. This is Railway Engineer Mechanics BDC41503. We are from Section 1, Assignment 2. For the group members, there's me, Anderson Tin Kai, Auni Zakira binti Zakir, Gopen Lun, Muhammad Aizah Hanif bin Sanif, and Muhammad Faham bin Badru Hisham. For the content, there's introduction, building methods overview, gas tungsten arc welding, gas metal arc welding, thermite welding, comparison of welding methods, and conclusion. For introduction, welding is very important for rail drills because it connects rail strongly and smoothly. It reduces maintenance and makes ride more stable. In this presentation, we'll explain different welding methods and how to check their quality. For the welding methods overview, there's electric arc welding, gas metal arc welding, thermite welding, and gas tungsten arc welding. For electric arc welding (ELW), this method uses electric heat to melt and drill rails. It's very strong and works well for thick rail section. It can be done manually or by machine. For gas tungsten arc welding (TIG), welding uses a special tungsten electrode and gas protection to produce very clean and precise fields. However, it's slower and needs skilled workers. For gas metal arc welding (MIC) welding is faster than TIG because it uses a wire that fits continuously. It's good for thick materials and large projects, but it makes more sparks and very dirty. And this thermal welding method uses a chemical reaction to produce very high heat that melts iron to drawing rails. It doesn't need electricity, making it perfect for on-site rail repairs, but the process needs careful setup. For the comparison of welding methods, EAW is strong but needs skills and costly work tools. TIG is very clean but very slow. MIG is fast but it's very dirty. The thermite is very cheap and convenient but harder to control quality. For the conclusion, welding methods are essential for creating strong, safe, and long-lasting rail joints. Each welding method has its own advantages and disadvantages depending on the situation. And lastly, proper testing is necessary to ensure every wheel is safe and meets quality standards.
Assalamualaikum and good evening everyone. Now our group we will be presenting about assignment 3. The topic for assignment 3 is wheel and rail contact mechanics. The introduction for this topic. The modern railway system has evolved for more than 200 years to meet growing transportation demands. Rail tracks are designed to provide a safe, durable and smooth running path for trains. As train speeds and weight increase, so did the complexity of rail-wheel interface. Thus, understanding wheel-rail contact mechanics is crucial for minimizing wear, ensuring safety, and optimizing ride comfort. The physical interaction that are related in this topic is divided into 3, which is forces, stresses, and deformation. Number 1, forces. Forces are separated into 3 forces. Vertical forces. Vertical forces caused by the train's weight acting downward. This includes both static loads and dynamic impact loads from uneven tracks or wheel defects. Next, the lateral forces. Lateral forces occur during turning or curve negotiation. It comes down from wheel flange contact and friction at the rail top. Lastly, the vertical forces. Vertical forces result from traction, braking, and thermal expansion of the rails. It can lead to rail buckling or misalignment over time. Number 2, stresses. High stresses occur at and below the contact point due to concentrated loads. Surface contact stress leads to wear and pitting. Subsurface shear stress can cause transverse fissures, especially in the rail head. Over time, these stresses can cause fatigue and failure of both wheel and rail materials. Here are listed the stress influencing factors, which is train speed, wheel diameter, rail and wheel surface smoothness, track geometry, vehicle arm sproutness, and lastly stiffness modulus. Number 3, deformation. There are 3 parts of deformation. The elastic deformation. Elastic deformation is a temporary flattening of wheel or rail at the contact point. It reverses once the wheel passes. Next, the plastic deformation. Plastic deformation occurs when the load exceeds material strength, resulting in permanent indentation or changes in shape. Lastly, the dynamic deformation. It is caused by sudden impacts such as flat spots and discontinuities. It leads to track misalignment, balance damage, and faster wear. Here are some of the effects of deformations. Increase in rolling resistance, poor ride comfort, noise and vibration, faster component wear, and risk of derailment. Conclusion. Rail-wheel interaction plays a central role in the overall performance of rail systems. The effective management of forces, stresses, and deformation reduces maintenance needs and improves operational safety. Incorporating precise engineering design, high-quality materials, and regular maintenance helps extend the lifespan of rail infrastructure. Understanding the wheel and rail contact mechanics enables more efficient, safer, and sustainable railway operations.
Assalamualaikum, my name is Muhammad Aizat Hanif bin Sanif and I'm going to do a presentation on assignment 4. Assignment 4 includes introduction, causes of rail crack, methods to detect the fatigue on rails, recommendation and also conclusions. Firstly, on the introduction, a rail track condition directly impacts safety and reliability. A fatigue failure is defined as a cause by repeated load cycles over time. It can cause microcracks. Microcracks occur at weak points such as bolt holes, weld joints, and also railroad corners. Some of the factors are axle load, wheel rail contact pressure, and also material fatigue limit. One of the ways to detection in fatigue is non-disruptive testing, or known as NDT. Second, I'm going to present on the causes of a crack. The first reason is due to the mechanical load stress on the material fatigue. Secondly, a crack orientation that can be caused by angular crack worsen stress. Thirdly, it's material defects. On the fourth is residual stress due to welding, heat treatment, and also grinding. The fifth causes of rail crack are environmental effect due to temperature and moisture. And lastly, it is due to operational conditions. Next, I'm going to present on the methods to detect fatigue. So there are also few methods that we can use to detect fatigue on the railway tracks. Firstly is visual inspection. Number two is magnetic particle inspection. The thirdly is ultrasonic testing. The fourth is AI integration by using the AI technology. And lastly, a nonlinear ultrasonic testing. As a recommendation, firstly, the material selection is important. We can use the fatigue-resistant alloys. And secondly, a predictive maintenance using a smart sensors to monitor the rail conditions. Thirdly, we can use design improvements by minimizing the joints and also to ensure the precise alignment of the rail tracks. And lastly, an automated monitoring using AI-enhanced vehicles for real-time monitoring inside the rail system. In conclusion, rail fatigue threatens the safety and reliability of the whole rail operation system. It must be addressed by using a preventive design and maintenance. A proactive, data-driven, and innovative strategy will ensure a safer operations, lower maintenance costs, and extended rail asset lifespan. That is all from Group 4, Assignment 4. Thank you and Assalamualaikum.